Hey guys, today we're going to be taking a look at compound inequalities. So compound inequalities are inequalities that you might actually hear in everyday conversation. So we talked about this just briefly, but a good example of a compound inequality is when people say they received between uh, $10 and $15 per hour at their job. So you could say the amount of money that they make per hour is between 10 and 15. So really it's kind of two inequality statements in one. It's this one right here and it's this one right here. So if somebody came up to you and said that they make between $10 and $15 per hour, so basically they tell you this inequality right here, you you would you would make a guess like $11, $12, $13, $14, 10.50, 14.50, something like that, because it satisfies both of these inequalities. So when they write an inequality like this, that means that both things have to be true. You wouldn't guess $50 because $50 may satisfy this part of the inequality, but it doesn't satisfy this part. Or on the other hand, you wouldn't guess they make $1 an hour because it satisfies this inequality, but it doesn't satisfy this inequality. So this is a situation where both parts of the inequality have to be true. There's also a situation where either one could be true, and we'll look at that later. But let's start with some ands. So real quick, got some work still left on here. Real quick, let's just go ahead and split this one up. So if I was to say this, I would say -5 is less than or equal to x minus 4, which is also less than 13. So we're just going to go ahead and split this up. We got this one right here, and then we also have this one right here. So we have -5 is less than or equal to x minus 4. And then on the other hand, we also have x minus 4 has to be less than or equal to 13. So there's kind of a big and symbol between those. These both have to be true. Otherwise, we'll find things that aren't in the solution set. And we'll call this a solution set because our solution is not just going to be one number. It's going to be an infinite set of numbers. So let's just go ahead and solve these. We'll add 4 to both sides. And we get -1 has to be less than or equal to x over here. That looks pretty good. I could rewrite this so that x was on the left-hand side. I might not do that right now just because it's a compound inequality. We might do that later. And over here, I'll also just add 4 to both sides. And I get x is less than or equal to 17. So I think first we'll just graph this. So if I graph this, whoa, it's hard to draw a straight line on here. Let's try that again. Try it one more time. Here we go. There you go. Wow. Okay. So this says that x is, if I was to rewrite this, x is greater than or equal to -1. And this is easy to read. So x is greater than or equal to -1. So let's just put a -1 down here. We could also put it in a 0 if we want. We don't have to. Let's put in a 17 because we're going to need that too. So this says x is greater than or equal to -1. So remember, we'll put that circle right on -1, and we have to fill that circle in because x could be -1. We want to include that in our solution set. And then we know if we just had this, we would just go on forever, right? If somebody just told us this information, we might guess 30, 40, 50. That would all be part of just this solution set. However, we have what you could say is multiple constraints. X must also be less than 17. Well, that's pretty much going to stop us right here at 17. Sorry, less than or equal to 17. So we'll fill this up. And so we just kind of have like a dumbbell looking thing. X has to be between -1 and 17. So a couple ways we could write that. I could write our X in the middle. We could write it like this. So it's basically just combining these two pieces, writing my lower limit over here and my upper limit over there, and just putting the appropriate signs in. And then we also have what's called interval notation, where we would say our lower limit, -1, comma, our upper limit, 17. And we want to put a hard bracket here, or a square bracket, meaning that it could be -1, so that's that equals to. And then we also want to put a square bracket over here, and this would be our answer in interval notation. Here's the graph, here's the answer in interval notation, and here's the notation that we're more used to. So let's take a look at another one. So here's another example of an AND situation. You'll see what makes these an OR type situation later. But let's just follow the same steps. I'm going to do this one much quicker. So we have -12 is less than or equal to 2 minus 5x. Or this, and this must also be true. 2 minus 5x has to also be less than 7. So both of these have to be true, since it's all just written out in one big inequality. So we'll solve this just how we always would. We could subtract 2 from both sides, and we'd get -14 is less than or equal to -5x. And then we would divide by -5 to get rid of that 5x by itself. And so over here we get 14 fifths, which is a fifth less than 3. And then over here we get, that's just a 1x. Now remember, we divided by a negative number, so we have to flip this sign. So there we go, we're done on that side. Over here, it looks like we'll want to subtract 2 as well. And we get -5x is less than or equal to 5. We'll divide by -5. And we get x on this side, and we get -1 on this side. And remember, we have to flip this sign since we divided or multiplied by a negative number. So it's now going to be this sign. So now here we have our two constraints. Might be easier to graph first. Actually, let's write it out in one big sentence. So let's put the x in the middle. We know we have these type symbols. X is between two things. 14 fifths is our upper limit, and -1 is our lower limit. So this says -1 is less than or equal to x, which is also less than or equal to 14 fifths. So let's see here. Let's do it on a number line real quick, just like last time. So let's say over here we got -1, maybe we got 0, we got 1, 2, 3, and 14 fifths is 2 and 4 fifths, right? So we'll put that right there, 14 fifths. So we're going to put one of our endpoints over here, one of our endpoints right here, and I'm filling those in because it could be those. Those are included in the solution set. And since both of these things have to be true, x has to be greater than -1. Well, that's all this stuff. And it also has to be less than 14/5. So I'm going to stop right there. I could also write the solution set like this. -1's my lower limit. Upper limit is 14/5. And both of those are included in the solution set. So I'm going to do those square brackets. We'll make sure to let you know on a test or whatever how we want you to write the solution set. But right now, be prepared to write it this way, and this way, and this way. Let's look at an OR type situation. So when we have an OR type situation, it'll actually have the letter or the word OR written in between them. So this happens less frequently in real life, but it does happen where somebody gives you an inequality constrained by ORs. So say your mom and dad aren't going to be, or say Mr. Bridenstine isn't going to be in his office between the hours of 3 and 4. So we could say you either have to come before or you have to come after 4. So it does happen, and I would rarely make you solve an inequality to figure that out. But we'll do the same thing here, except now we'll look at this a little bit differently. So we're still going to solve each one individually. So let's go ahead and just add 1 to both sides. And we get 4x is greater than or equal to 8. Divide both sides by 4. We get x is greater than or equal to, sorry, I should have put the 4 there, greater than or equal to 2. So we got one part of this right there. Or we got this thing right here. So I think I want to change this. I don't think I meant to do that. So let's do it less than. Let's do that. Yeah, see how this goes. Okay, so we have to first multiply both sides by 2, right? To get rid of this 2. Denominators always make things hard. So now we have 9x is less than 6, right? And let's see here. We would have to divide by 9, it looks like. So we have to divide both sides by 9. And we get x is less than 6/9. 6/9 is also the same as 2/3. With a big fat or in between these. So let's see here. Let's draw this on a number line to see if this is even possible. So let's see here. Let's say we got 2 right there. And then let's say we got 1 right there. Then maybe this is 2/3. That's 1. We don't need to include really any numbers besides the numbers that we're dealing with, but sometimes it's helpful. So x is greater than or equal to 2, so let's just graph them separately. So greater than or equal to 2. So we got to fill this in. And then greater than means it could be like 3. That'd be okay. So we're going to have this arrow pointing this way. We'll kind of shade that in. Make sure we have a nice arrow at the end of it. Shows that that goes on forever. And then let's graph this one. X is less than 2/3. So here we got 2/3. I'm going to draw an open circle. I'm not going to fill it in because I don't want people to think that 2/3 is part of the solution set, because it's not. It has to be strictly greater than or less than 2/3. And then what's less than 2/3? Well, all this stuff over here is less than 2/3. And that's actually what the graph is going to look like. Notice how there's no overlap. So before, when we looked at ands, like in this one, what we were counting is only the overlap. We're only counting where both of these inequalities were both true. This had to be true and this had to be true. That's why we didn't keep drawing this arrow all the way over here. But now either one can be true. It's very it's very nice in that way. It's pretty loose. So either one of these could be true, so we could write it this way. We kind of have two separate solution sets here. We have, I'll write it in interval notation. So the lowest thing it could be on this side is negative infinity to 2/3, and 2/3 should not be included. And then we're going to put a comma because that's the end of this interval. And then we have another interval that starts, and it just goes from 2, and 2 is included, all the way up to regular old infinity. And again, infinities are never included because they're not real numbers. And this is how we could write the solution set. Or you could write it this way. But be prepared to do both ways as well as graph. We got last one, and then we're going to, and then I got a couple problems for you guys. I'll try to wrap this up. Okay, last example. We don't have to take forever on this. Try to erase that. Did not. Here we go. All right. So again, we have an and. Sometimes they can even write ands as a word and not just like this. So we'll just solve these each individually. I'll add 3 to both sides. I get 5x needs to be less than 15. I'll divide both sides by 5, and I get x has to be less than 3. All right, sounds good. I'll solve this one now. So I get 4x has to be greater than 24. I'll divide both sides by 4, and I get x has to be greater than 6. All right. Now, if somebody said this to you, that say you were playing a guessing game, and they said, I'm thinking of a number, and this number is less than 3, and it's greater than 6. Well, there are no numbers that are greater than 3, or less than 3 and greater than 6. So you might start out graphing this, and you might put a 3 here, and you might put a 6 there, and you might put open circles. You should. And you'll say it has to be less than 3, so it's all this stuff over here with a big arrow. And it has to be greater than 6. And so it looks like that. This kind of looks like our previous problem. The only problem here is that instead of an or, there's an and. So it says both of these things have to be true. Well, as you can see, there's no place on the whole number line, there's no number that's greater than 6 and less than 3. So this is, if you do that graph just to show yourself, make sure you cross it out so you know that's not a true graph, because that is not actually the graph of this solution set. Go ahead and cross it out and just write no solution, because this is just an impossible situation. All right. I got some problems for you guys. I know this was a bit longer video, but there's kind of a lot of situations going on. I'll see you in class.